Okay. How many of you guys have inferenced a model before? Okay, the rest of you are lying to me. You have. Have you ever used ChatGPT? Claude? Okay, that's inferencing a model. Inferencing a model is just getting it to give you an output, to take the tokens that you gave it, put them through the model, and then get that output, right? And we can do that with something like ChatGPT or Claude, where we don't have to think about it, or we could use something like Ollama, that's open source, where we think about it a little bit more, or we could think about it a whole lot and use vLLM. And that's what we're going to do today. We are going to talk about how you make production inference happen when you actually are thinking about the entire process, right? How many of you guys have heard of vLLM? Yes? Okay, amazing, amazing, amazing. So vLLM is the industry standard for inference, and it is all about making sure that we are getting the most out of our GPUs, right? Hardware is very expensive. We hear about how there's a shortage for it. So we have to make sure that whatever hardware we have, we are getting a lot out of it and serving as many concurrent users as possible. Okay, so we're gonna talk, hopefully, one, about the value of running your models locally. I know not all of us have hardware, but all of us have laptops, right? And there's a lot you can do with CPU. Especially if you're running these smaller models. We'll talk about how we get these larger models to perform like smaller models via quantization. And then we'll talk about levers to tune your model deployments so that you're actually, doing the best you can. And it seems like you went to a talk to learn about it. And why quantization is cool. How many of us have heard of quantization? Amazing, amazing. And then some upstream communities to check out after so that you learn something, you have some homework. Okay, perfect. Why run models locally? First, model customization capabilities. So how many of you have ever fine-tuned a model, maybe? Okay, a lot of us, right? So if that model is smaller, it's easier to fine-tune. So if you're not familiar with fine-tuning is adding data to a model to shift those weights. So weights is loosely a synonym for parameters, and that is where the vectors have been placed in relation to one another to have the specific model that you now have, right? That we can download as a gguf file, a gguf, and actually inference. Okay, second, data privacy. I work for an enterprise company. We have a lot of clients that are banks, hospitals that have really sensitive data, right? And so it's a bit scary to be using a model, one, that you're sending your data off somewhere else, right, to somebody else's hardware, to the cloud. But even scarier to be doing that on a model that's continuously training. Right now, we're in an early enough phase in artificial intelligence that a lot of these models are taking in the data that you give them and using that to then train their models, right? So you would really hate to see some very sensitive data that you carelessly put into ChatGPT come out in ChatGPT 4, right? Okay, predictable cost at scale. I don't know if y'all have ever tried to estimate how much you are going to spend when you're thinking about tokens and the hardware you have and how big your model is, but there's a ton of factors, right? And so if you're an enterprise and you are thinking more long-term, it can be easier to get predictable cost when you have your own hardware and you're running models locally. Also, control over the entire stack. You'll see today just truly how much control we have over our GPU utilization when we are controlling our own inference deployment. Okay, so a car analogy, right? So it's the same as if you want to pay a subscription to one of these web hosted models, right? That's kind of like taking an Uber, taking a taxi, or you could lease and rent something. You could do something where you bought your own hardware, but you're gonna give it back, right? That's the cloud. Or you could have your very own infra that you work with all the time. That's kind of like owning your car. So think about what you want to do. And yes. Okay, about vLLM. Last year, it had the most unique contributors of any GitHub project. We have an insanely active community of people that contribute and work on this project. It is used super, super widely. It has day 0 support for all the major models, right? When a new model comes out, our engineers are scrambling to make sure that that also runs on vLLM regardless of the architecture. Yes. So you can see some of these big model names, right? Out of curiosity, what models do you guys use? You can shout them out. Llama. Okay, that's Meta's open source model. Who would have thought Meta would be the good guy in this, guys? Not me. Okay. Any models from like Asian labs? Maybe a DeepSeek, Quinn. Okay. What is it? GLM. I'm not familiar. No, I don't know. Is it? Should I be familiar? Okay, for agentic coding. Awesome. Are you guys mostly using these models for coding? Yeah. Yeah. That's awesome. I like DeepSeek a lot. Anybody using DeepSeek? Yeah. Yeah. So I use a quantized version of DeepSeek because, I want to be able to run it locally. I don't have a GPU. So we can do that. Okay. So as I mentioned, our engineers do compress these models and make sure they run on vLLM's architecture. If the next time you're on Hugging Face, which in my last talk, I assumed everybody was familiar with Hugging Face, and today's a little bit more niche, so I'm again gonna assume that you are, but in case you're not, I would say it's like GitHub for this AI era that we're in, right? It's where everybody's posting their models, it's where you can pull the models. Obviously, it's not like Git, right? But it is like a repository that we all share and is really prevalent and kind of becoming like a communal space. But Red Hat, who I work for, has our own repository of these models on Hugging Face, right? That we are going to tell you are safe, good to go. Yes, so if you need one, check it out. Okay, so now let's talk about evaluating and actually optimizing these models. One, just a bit of a definition. There's model evaluation, which is a whole big category that can be very vibes based. I don't know if you guys have ever seen LM Arena. If you haven't, it's a really fun thing to check out, and you can check it out after this talk. But LM Arena is this website where you have anonymous models give you responses to whatever query you gave it, right? So you gave it a query, you have two models, you don't know who they are, who made them. They give you prompts back, and you guess you say which one you liked more, right? And a ton of people are doing this. And then we have like a worldwide ranking of which vibes model which vibes of which model we like the best as like a large community, right? Super fun, awesome. And a lot of models do optimize for what people like, but that is not model benchmarking, right? Model benchmarking, what we're talking about today, is rather when we are looking at models and we are seeing how do they perform on this predefined set of tasks with this data set, how quickly are things moving, what's our inter-token latency, what's that time to first token, et cetera, et cetera. More numerical, more relevant when it comes to the SLOs that some of us might have when we are running AI in production. Amazing. Okay, the issue with deploying LLMs, this is the thing that we have to think about. So if you really want high accuracy, likely the thing that you're going to do is run a larger model, right? It's been trained on a bunch of data. For reference, OpenAI's newest release, people guess, is like 3 trillion parameters, right? Whereas like when I run something on my machine, it's going to be anywhere from 1 to 20 billion. Huge differential, right? And so because of how big that model is, it's going to be more accurate. But if I were to try to run something really big, I would get a lot of latency, right? It would be super painful to actually query something like that on my own hardware and expensive. Okay, so if I want to spend less money and still have that high accuracy, just slower, right? But if I want to have a really short amount of time and a really small cost, which is what I do, then I'm going to maybe run into low accuracy because I'm using a smaller model. So choosing the right model and the right performance for whatever your case scenario is super important. And I would say these are the 3 trade-offs that you're considering, right? It's not new to us as engineers, right? Like latency, cost, how accurate. Okay, there are many model choices for us to think about, but after we're there and we know what we want to use, we have to think about application priorities, right? There are so many different hardware setups, but we have to define performance and quality thresholds so we know what's actually useful. For a chat assistant, for example, we would say best practices, and obviously this is a very new industry, right? Like things are still being defined, but we would say time to first token, which is the time it takes for you to get that very first little like chunk of text when you're querying an LLM should be under 200 milliseconds, right? For 99% of request. The time to first token is typically going to take longer than the time in between all the other tokens. And that is because of the way the GPUs work, right? When you are waiting for that first token back, you're in the prefill phase, which is dependent on something different than what the rest of the streaming is dependent on, right? So for that inner token latency, you want a fourth of that time, right? For 99% of request. Okay, but then RAG, if you understand how RAG works, right, where we are having data that's being added into our context window, right, we're scanning a lot of data, there's going to be way more input tokens because we're pulling in context more so than just what that user gave us. We are going to have a larger time to first token, and that's okay, right? There's more to process, and a bit more inter-token latency as well. Okay, Guide LLM. This is the first project that I'm gonna say, this is your homework, check it out. It is all for benchmarking your LLM deployment and going beyond that model to, okay, what can we get out of this model on this hardware when we have this many users and this type of traffic? And you can set all of those parameters so you can have some intense numbers, right? Some solid numbers and less surprises, right? Amazing. Okay. So this is the user flow. You pick your model, you pick your data set. There's some cool options for synthetic data we can talk about. I know having data sets is not like just something we all can just pull out, right? You have to clean data. I think synthetic data is a really good option for trying things like this. And you can see, okay, how does it work with my data and my model? And then you can configure your workload. So in certain case scenarios, right, maybe you have a ton of traffic coming in at once. Maybe you have a little bit of traffic trickling through. It just depends upon where this is deployed. And then if the model meets your desired SLLO, you can deploy on hardware and hopefully with vLLM. Okay, so here are some deployment metrics that we think about, right? So throughput. How many responses can you give out per second? The request concurrency, how many people are hitting my endpoint? Tokens per second, how quickly can we stream? We went over that earlier. You guys can take a second to read some of the rest of this. Sparkling. Thank you, Europe. Okay. Simulated workload rates. Here are some of the type of workload rates that we're going to run into, right? So concurrent is just a fixed number of users, and you guys can see the rest of this. Asynchronous workload is going to be when you're running a single stream of requests at one time, et cetera, et cetera. This is my LinkedIn profile from last year. Okay, data sets. Different data sets are going to be different links, right? So chat, we have, the prompt is probably going to be about 500 tokens. And just for like an idea of how much a token is, it loosely correlates to a word. It's not just like what we would have in the English language, right? One word equals one token, because we're not the ones determining. But loosely, it's about 500 words, right? Output, about half of that. With RAG, as I mentioned before, we're taking in a lot more, probably around 4,000 tokens. And then the output is going to be about twice what it is for chat, right? Summarization, that's a use case that a lot of us use AI for, summarizing things. The prompt there is probably going to be about 1,000 words, and we're going to want to get about a fifth of that. And code generation, we hopefully are giving detailed prompts so that we have our assistants know what we need, and they're hopefully giving us about the same amount. That's not always true. Sometimes we're doing like 2 sentences and getting an entire application, but in the best case scenario. Okay, so this is how you would configure a workload for chat, that first example that I just showed you. The model here, you can see kind of what the CLI looks like. It would be vLLM serve, and you have your model name right here, Meta Llama. I know we had somebody using that. Great model. 8 billion parameters is an awesome size to run on your local hardware. Instruct just means that it's fine-tuned. If you guys see that word on Hugging Face, quantized, yes. Okay, and then you can see right here, we have our endpoint, we have the rate type. So we're doing a sweep right here where we're running synchronous and then concurrent. So very small amount of requests, then a huge amount of requests, right? And seeing what we get from that. And then our SLO here is under 200 milliseconds for time to first token, 99% of the time. Dataset profile, amazing. Pretty cool. What would be the problem, right? Like, what is the max request per second that I can get on a single L40 setup, and how much can that handle? And therefore, like, meet my SLOs, right? And if the answer is it can't handle what my enterprise is asking of me, then we can just size up our hardware just a little bit, right? Instead of throwing a whole bunch of stuff at something that maybe is a smaller problem. Okay. Some methods of making models smaller. 1, distillation. So you can teach a smaller model to act like a bigger one. This was super big in 2023 when we first all started, where we were having these larger models generate synthetic data. And to some extent, I think this is still something that a lot of the big labs are doing, and then training these smaller models on them, right? And so then you're hoping that you get the same amount of knowledge from that bigger model that you're now transferring to that smaller one. Okay, quantization. Super like standard. This is what we're all doing. We're shrinking and reducing the precision of the numbers inside the model, aka the parameters, or the numbers that we are getting when we are querying the model, aka the activations, right? And the way that I think about this is pi, right? We all probably had that experience in lower school where we are trying to memorize as many digits of pi as possible. And we can go on and on and on and on and on, and that's pi. But if we still say 3.145, that is still pi at a much less precision than what pi could potentially be, right? That's quantization. These numbers are very precise, but we can round them and make them a bit duller and still maintain a whole lot of accuracy. Okay. Sparsity. We can set some of the numbers to zeros. There are various methods of doing this, but you could imagine that some weights matter less than others, right? Like some parts of the model are really essential to getting good outputs, and some parts are probably some like outlying knowledge that we're not really touching all that much. And there are some ways with things like MLflow, another project that I'm not going to talk about today, but I would recommend checking out if any of you want to understand model internals, that you can see what all is going on there. Okay, compression. This is just like when you take a photo and you save a less sharp, blurrier version of it, right? Just saving this into a compressed format. Okay, so quantization is what I want to talk about. And we can convert full precision weight, which is FP32, right? If you see FP32, that is the model as it was trained. That is as precise as the weights get, but we can put it in lower bit formats, right? So FP16 into 8 into 4, and that is how you know that things have been quantized, right? And that's going to reduce our memory footprint and make it easier to deploy these models and increase their speed, right? We mentioned earlier that I use DeepSeek quantized version so that I can run it on my laptop. There are multiple quantization algorithms and approaches, right? So I mentioned the weights, and the weights are the parameters, are the shape of the model and how the data relates to one another, and the activations is all of that matrix multiplication that's occurring when you take your prompt and you integrate it with the model to get a response, right? Lots of activations that are occurring there, and you can quantize both. Okay, an option for quantizing. LM Compressor, another open source project, but you can pick your algorithm with this one, and you can do sparse GPT, smooth quant, and decide how you want to compress that model, what works best for you, and then inference it with vLLM potentially, Ollama maybe. Here is a compressed DeepSeek R1 model, wink wink, and how it performs. Yes. So you can see that these different colors represent different levels of quantization, and it is pretty similar across these various types of quantization, right? For the level of reasoning that it got, we're recovering 97% accuracy using Int4 quantization, which is we're seriously quantizing with Int4, right? For 7 billion and larger models, right? And then that loss in accuracy by 3% is then going to deliver 4x better inference performance when it's time to run that model. Okay, LM eval harness. Okay, so this is to actually check in on the model itself. There are a huge variety of different tasks that you can check an LLM's performance on. This is an open source project where you can run various tasks. So LM eval harness. Okay, and then these are the resources that I would say I've talked about today, and I want you to check out vLLM 1, Guide LLM 2, and then LM eval harness. I can show you guys some fun things, or I would love to do some questions for a minute. We have started a newsletter. It doesn't come out more than once a month. If you want to join, please do. I write some cool blogs about quantization, etc. I just did one on agentic security that I'm pretty excited about with a new project called KGenty. Yeah. Any questions? Yes.
If you're seeing such good returns for a quantized model after training, is there any idea to quantize the weights before training or just to train to a lower precision?
So quantizing is definitely something we're doing after training, right? I don't know what's going on before training. That's not something I really have visibility into. There could be, let's quantize this, let's whatever. But mostly what I'm doing is I'm getting these models, these base models after they've been trained, and I'm trying to see, how can I get the most out of them? And that's what I'm quantizing, right? But it is such good results that you would imagine that the people actually training the model are definitely taking notice and adjusting, right? Yeah. Yeah. What's up? Oh, we got a mic.
Yeah, I got a mic. Thanks. When you say you run your models locally, do you really mean your laptop, your MacBook?
Yeah,
or?
my laptop, right? So vLLM can also run on CPU.
Yeah, but a DeepSeek model, even if you quantize it to 4-bit, is 300 gigabytes. Which kind of MacBook do you have?
I have a pretty beefy company computer,
Nice.
but I'm also using their R1. So their very first, not their version 4, bigger one. So yes, it works. It is a little slow. Okay.
I just wanted to ask, because I was checking out the docs of vLLM previously.
Cool.
So, and there was written it's a little bit experimental on MacBooks. So
Yes. Yes. So if you don't have more than 4 concurrent users, I would go Ollama, right? How many of us have worked with Ollama? Yeah. But if you do, then CPU is something that they're working on, and it works, but you're definitely probably jerry-rigging it a bit for now.
And is there, in comparison to Ollama, if I use vLLM, do I get a better performance? Because Ollama works out of the box for me, but it's a little bit slow for some models. So would I get a performance increase if I were to use vLLM instead?
Yeah, definitely a performance increase. I don't know how noticeable it would be if it's just you, but it's going to become really noticeable at scale, right? So if you're actually deploying these things, then definitely big performance increases.
Okay, thank you.
Yeah.
Thanks for the talk.
Of course.
Running the models on your laptop, it's cool and useful, but if you're using it for agentic coding, would you always end up using the cloud stuff for doing your real work? Or can you actually use it properly off your laptop to get stuff done? Or is it okay, now I'm doing my real job, so I'll hop over to Claude and
Unfortunately, when I'm doing my real job, I probably am querying things on the cloud. I really hope that is not where we end up. I think especially as we start seeing ads ads in a lot of these models. Like we are in like the golden era of free AI right now, but these companies are hemorrhaging money, and eventually I think it's going to be a lot less fun to use them, and these local models will become more and more important. But when I'm actually like writing code or doing things for work, I'm not going to mess around with a local deployment. Also, because my company is paying for my tokens, right? So, yeah.
Yeah, how far you can take this? Because I recently found a bitnet from Microsoft
Okay.
for 1 bit
Yeah.
inference. So, is it any? Do you know any like practical limits on this? So, how far you can take the quantization?
Very far, right? Like having like one parameter does work. It would not be what I would use for like a general purpose model that I just want to be able to ask like whatever question to. But I think we have sort of seen this technology as a solution without a problem, right? But as we all kind of like zoom in on what we actually want to do, I think the use cases are probably a lot more specific than what we're currently using them for, right? So these 1 billion parameter models could be really good as a part of an entire workflow, right? Where this one model is doing this one thing and it does not need all that much in order to like create some context that I pass on to the next step of my workflow. Yeah.
Just something else that came to my mind, because you talked about the quantization, and is it possible to combine it with compression, or did I understand something wrong? So I can have a quantized model for 4 bits, 8 bits, and then can I additionally compress it to make it even smaller?
Yes, you can combine a lot of these things. There are infinite possibilities, which is why Guide LLM is such a cool project to see like how does this model that I've played with, that I've compressed, that I've quantized, how does it actually perform, right? There's still a lot of questions and a lot of possibilities here. So yeah, totally. I haven't done it, but I would imagine you definitely could.
Thank you.
So I wasn't aware that Red Hat and vLLM are kind of like Red Hat contributes to vLLM. Could you
Yes.
maybe elaborate a little bit on what are your focus things there where you contribute?
Totally. Okay, so we acquired a company called Neural Magic, which is the company that put out vLLM. A lot of former Red Hatters actually worked there. We acquired them, and now 20% of the vLLM contributors sit in-house at Red Hat in our AI division, right? So initially we were definitely thinking like, let's talk about model customization, let's add models to data, let's do fine tuning. That's the kind of the umbrella of projects I was advocating for recently, but we've seen that inference has been so much more fruitful as we're all like actually going into production and these models are becoming a bit of a commodity, right? That yeah, like vLLM has definitely been our project with the most interest that we have crazy numbers at for our meetups, that Red Hat definitely prioritizes from a business strategy as well. Yeah. There's also a bunch of projects that sit within vLLM. They're really innovative. They're always doing new things. So it's definitely been really cool to get to follow and to get to work with those engineers. So smart. So smart. Hey.
Thank you. I have another question about sparsity, if you're willing to talk about it. Could you
Yeah.
say the name of the project for that again? And
Sparsity, yeah, LM compressor.
compressor.
LM compressor will allow you to compress models with different algorithms, right? I've never worked with sparsity. I just hear about it as like something that people do, right? And I think the logic behind it does make sense that certain weights would be less essential in a model.
Do you know how you choose or evaluate which weights are essential?
ML Flow.
though?
That's the
Okay,
project you're looking
ML
for. Yeah,
Flow, okay.
ML Flow
Yeah.
is cool for like actually visualizing those weights and seeing what all is going on there.
Cool,
Yeah.
thank you.
Other observability stuff worth shouting out. Grafana, if you guys have checked that out. Jaeger, cool for like when you're actually doing AI workflows. And when you're working with AI agents, like, the amount of like tool calls and logs that a single prompt can generate is pretty wild. So it's awesome to get to have that level of observability.
Thank you.
Yeah, of course. Any other questions, guys? Amazing.
So you talked about guide LLM to evaluate the LLM. So in the example that we saw, it was like, okay, what's the time to the first token and all the other values? Is there also a way, because a lot of times we see like benchmarks for new frontier models where you have the SV benchmark and these other things. Is there something similar, maybe smaller in scale, that I could use? So just to see, okay, I have compressed the model, the time to first token is good, but at this point I don't have any information. Okay, is the output worth anything? Is there something where that I can just, like with a line of code, do some computation to see how good the output of the model is, or do I have to do it by hand and by feel?
No, that's a great question. Are you familiar with Podman by chance?
No.
It's a Docker alternative, and they have a desktop. So you can use Podman Desktop and download their AI extension. And they have a great playground, right? So you can pull in these models, run them as containers, and then change some of the settings like top P to decide how creative or just absolutely accurate these models are going to be. That's a really good place for querying models and seeing like what you like the actual output of.
Okay, thank you.
Yeah. Shoot. I can show you guys a little bit more about Guide LLM too, if you guys are interested. We have more time than I thought. Really great questions though, guys. Oh, this is fun. 2023, remember earlier I was talking about like, we were definitely thinking at Red Hat that it's like the year of LLMs, let's add data to our models. And then we were like, oh, maybe not. Like maybe we could just use RAG. We don't have to like actually fine tune these models as much, right? And get like pretty good results. And then it was all about agents. And then now I think it's going to be about evals because we're actually in production now. So I'm glad you guys are here. When I asked you guys to raise your hand, it sounded like you all are pretty familiar with a lot of this stuff, which is an indication that maybe evals are actually what's up. We hope so. Not financial advice, obviously. Let's check this out. Another thing for if you're like, oh, I don't want to do all of this myself, and I'm sure a lot of other people have, Artificial Analysis is a cool website that actually ranks all of these models based on different criterion. So intelligence, right now, they're saying that it's ChatGPT's 5.5, right? And then Nematron down here, but these are like the top guys, right? Speed over here, and then price over here. Is anybody surprised? I kind of am seeing this, right? Like I think that this being here and here and here is kind of scary. Yeah, this is a cool website. And then I can show you guys LM Arena as well. Okay, what's our prompt? Not today. Ooh, interesting. Okay, so the format's so different. So the first one gave us kind of like, oh, interesting. Ooh. Okay. All right, so Assistant A started with like a little blurb, right? Oh, Assistant B is still going. Assistant A is like a little blurb. They're both state of the art, both open source LLM, serving frameworks, and then core architecture and innovations. Page detention, definitely interesting. It treats KV cache like virtual memory, right? vLLM. Yes. I don't know what they've got going on. And then feature by feature, who they were developed by. Okay. And then Assistant B, it gave us a list of 10 things, right? So philosophy, design goals, performance, a little bit more emojis over here. Oh, I like that it has benchmark notes. Feature list as well, ease of use. Okay, what do we think? Do we prefer A or B? Raise your hand for A. It was faster. That's something. B? Okay, we liked B. Okay. Oh, yeah, yeah. Okay, that was Mistral. Mistral is a French lab that produces this model, and then versus Gemini 3.1. Pretty cool. Okay, let's try again. Okay, so this one's done. We got some links from this, like we got the YouTube channel. We have a list of the family of different events. Okay, A, B. Okay, B again. Gemini this time won versus GPT 5.4. Interesting. Isn't this fun? I have time. I'm just burning time. If y'all are like, I need another coffee, go get it. But I'm just gonna hang out here until that clock runs out. We got 11 minutes. Okay. Oh, let's see what else can I do? What else do I have up my sleeve? Yeah.
LLM project, like especially when you show the costs right now, what we are dealing with right now is the issue that, like for some tasks, we mainly can rely on the cheap models, like let's say a GPT or S120B is fine for many tasks, or like a flash version of some of the big models. But as soon as you get to the more complex tasks, especially in agentic programming, you would like at some points, like take the big ones, or like an Opus model or something like that.
Yeah.
And I know some people are starting with these like dynamic routing of two models, like having a cheap model, evaluating the complexity, and then routing to the right model. Any part of the vLLM project going in that direction that you're aware of, or in Red Hat?
Yes. Great question. There two things I want to say. One, yes, hopefully that's exactly what we're doing. We're deciding what actually needs this larger model, what actually needs this smaller model. And I think with agentic workflows, it's probably going to be the things that a failure has a really high cost, right? It affects everything else going on in that workflow that we're going to want to use that expensive larger model. But as for things going on in the project that are going in this direction, we have semantic router, which all of us are super excited about. And the way this works is we have both a small and a large model ready to generate outputs, right? And we start with having that smaller model generate the output, and then having the larger model evaluate the smaller model's output in a single pass. And wherever it hallucinates or goes off the rail, we cut it off right there, and then that larger model fills in the rest of the tokens. So you end up with mathematically the exact same level of accuracy as if you had just used that larger model the entire time. But you're not, right? You're still going to get the benefits of things being smaller, cheaper, faster. So yeah, semantic router is really interesting.
This means, just to understand it, right during you stream the tokens, and at some point you cut off and say, "No, I evaluate."
Yes. Also, spec decoding is another word for it. Speculative decoding, speculators. You'll probably see that in the project if you read through. Yeah.
Okay, thanks.
Yeah. Okay, guys. That's probably it from me. But I hope we took away why it's all important to do all this stuff. I'm going to be at the Red Hat booth for the next couple hours. Happy to talk about all this. I hope you all go home with some cool open source projects. Thank you so much for your time. I really appreciate it. Bye, guys.